Hi everyone. Today we'll look at lesson 1.4, Domain and Range Graphic Organizer. So we're going to begin with the definition of a domain. The domain of a function is the input values of a function. And the input values of a function is going to represent what is happening along the x-axis. So the domain will represent the x values. If we take a look at the range, my definition of the range would be the output values of a function. The output values represent what is happening along the y-axis. So today, we are going to locate the domain and the range of a discrete function, a continuous function, and a word problem. Let's take a look at a discrete function. Discrete. Anything discrete can be counted. And we could count the points on this graph as 1, 2, 3, 4 points. That represents a discrete function. The first question they ask us is, what is the domain of the graph? Now, if we look back at the definition under domain, the domain is the input values, which are the x values. So we're going to take a look at each point, look at the ordered pair, and find the domain of this discrete function. Our first point that we look at, and we want to read the graph from left to right. We have -3, -4. If I ask you what was the x value on this point, you would tell me -3. That's my input value. Okay, now let's go to our next point, which is here. All right, because remember, x is from left to right. We have -1, 3. If I ask you in this order pair what would my x value be, you would tell me -1. Okay, now we're running over, bam, we got another point, which is 2, -1. If I ask you what my x value is here, you would tell me 2. And right here, we have 0.3, 5/2. And remember, the domain is the x value of the function, or the ordered pair, and we have 3. So the domain of this discrete function is going to be -3, -1, 2, and 3. Now let's take a look at the range of the graph shown. The range represents the output values of a function. And remember, the output values are the y values. This is our y-axis. We want to read it from bottom to top. Okay, so this time we'll be going this way instead of this way. All right, let's start with the range. Remember, they're the y values. So let's start at the lowest point. And we have -3, -4. If I asked you what the y value was, you would tell me -4. All right, let's go up. And we have 2, -1. If I asked you what the y value is for this point, you would tell me -1. All right, and we're moving on up. And we have a point here at 3, 5/2. The y value for this point would be 5/2. And the last point that we reach would be -1, 3. -1, 3. If I asked you what's the y value, you would tell me 3. So the range of this discrete function is -4, -1, 5/2, 3. Now, moving to a continuous function. A continuous function is something you can't count, but you can trace it. And notice I could trace this line, and I can trace it and my pen doesn't pick up. So whenever something is continuous, you can put a pin on it and you can trace it. The continuous functions domain is going to look a little different than the discrete functions domain. Discrete can be counted. Continuous we can't count. So we're going to have to use some inequality signs. Whenever we have a closed circle, we have a line under the inequality sign. And I want you all to practice whenever you see a closed dot or an open dot, you need to do this first. Our closed dot is going to be less than or equal to. The closed dot always gets a line. And remember, we're reading from left to right and bottom to top, so it'll be less than or equal to. And since this circle is open, it doesn't get a line, and we're just going to simply use less than. So with continuous functions, you'll use either less than or equal to or less than. Now, what is the domain of the graph shown? The domain represents the x values. So I must represent the domain as x. Now let's look at my alligator mouse. Notice that less than or equal to is on the left side. So we need to place it on the left side of x. And the less than sign is on the right side, so we need to make sure that we place that to the right of x. Now we need to see what the x value is. Now, we're only looking at the x-axis numbers. That's it. So what I'm going to do is take my pen and walk to see what number that is. And notice it's a -3. Now, let's go to the less than sign. Notice on the x-axis, that falls on the number 2. So the domain for this function would be -3 is less than or equal to x, which is less than 2. Now we're going to take a look at the range of a continuous function. Remembering that the range represents the output values of a function, and the output values are going to be your y values. So let's write that down right now. The range is the y-axis, so remember we read it from bottom to top. Okay, bottom to top. Now, if we look at the point, notice that the lowest point is at -5. So we know -5 is going on the left side. We have a closed circle here, so we know our sign is going to be less than or equal to. Now, don't let it confuse you. I want you to take your pen or pencil or marker, and I want you to only drag it along the y-axis, and we're going to stop at the highest point. So if we go up, 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 is this the highest point? No, keep going. Up, 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 up. Up. This is the highest point of this graph. So let's put a mark right there. Now, what number did it stop on? It stopped on 4. Now, do you see an open circle? Yes or no right there? The answer would be no. So we have to use the less than or equal to sign because it's saying it's closed here. So even though you don't see a circle, since this line does not separate with an open circle, it includes the number 4. So the range of the function would be -5 less than or equal to y less than or equal to 4. And last but not least, a word problem. Now with the word problems, we're going to want to place some of these in the calculator. And I'm sure you have the lesson for the calculator problem. Whenever you see an equal sign, we know to go to y equals. All right, but let's read the word problem first. The total cost in dollars to buy uniforms for the players on a volleyball team can be found using the function C equals 46.50 U plus 15, where U is the number of uniforms bought. If there are at least 9 players, but not more than 13 players on the basketball team, what is the domain and range of the function for the situation? And we playing volleyball, y'all. Volleyball. So let's cross that basketball out. Now, we're going to input something to spit out something. They give us U is the number of uniforms. Okay, so if we look at the problem, we have C equals 46.50 U plus 15. And in this case, our domain will be U because those are the input values. Those are the uniforms. So we input how many uniforms we have to output C, which is the cost. So the output would be C. So the domain of this function, we're going to be looking at the number of uniforms, and the range of this function will represent the cost. If we look at this sentence, it says, if there are at least 9 players, but not more than 13, the number of uniforms we'll have is 9, 10, 11, 12, 13. Now stop because it's not more than 13 players. So we have to have 9 players on the team, but we can't have more than 13. Now, we're going to take these numbers and input them in a function to spit out a cost. So, for 9 uniforms, the cost would be $433.50. If we input 10 as U, we have $480. If we input 11, we get $526.50. If we have 12 uniforms, it's $573. And if we purchase 13 uniforms, we have $619.50. All right. So today we covered the domain and range of a function. The domain is the input values of a function, which represent our x values. The range is the output values of a function, which represent our y values. And today, we looked at the domain and range of a discrete function, a continuous function, and a word problem. You guys have a great day.